Okay, so this will be our lesson 3. So today we will be there will be two video uploaded separately. One will be improper integral, then the other one will be volume of revolution. So this is the first one, which will cover the part for improper integral. Okay, so before we move on, right, so I want to talk about these two things first, so make sure that you can understand this idea, so as we move on it will be easier for you to understand the everything that we will be discussed later on. Okay, so the first thing is, let's look at this. So the arrow here actually mean approaches, meaning like nearer and nearer to. Okay, so what happened here is that actually when n approaches infinity, so meaning that when n get nearer and nearer to infinity, what happened for a number a over n? So a meaning can be any constant or any fraction, then divide by your n that is approaches infinity. Okay, so maybe for this case, let us try to put our a be 2. Okay, then we try out. Okay, so n approaches to infinity. Maybe let us start with 1. So let's say if n equals to 1, so meaning that is going to be 2 over 1, which will actually gives you 2. Okay, so n approaches infinity, so meaning all the n that we substitute here must be greater and greater. So let's move on for maybe 100. So when I put 100, it will become 2 over 100, which will give me 0.02. Okay, then after that, move on to maybe 10,000. Okay, then I'll be getting 2 over 10,000, which gives me 0.0002. Okay, so as I increasing the n number again to like maybe a million, so I will be getting 2 over 1 million, which will give me 0.000002. Okay, so what happened when you see when the n number getting greater and greater? Okay, like for the n number is getting greater and greater from 1 to 1 million. Then what happened to your fraction here? The fraction actually, the value of your fraction actually decreasing. But will it possible that you will get a negative value? It won't be. So all this value actually getting smaller and smaller and approaches to 0. So you remember the first thing, when n approaches to infinity, a over n will be approaches to 0. So that's the first thing. So now let's look at the second one. When n approaches to 0, what happened to a over n? Okay, so the same thing, maybe let us try to use 2 also. So let a be 2. Okay, so this is approaches to 0, right? So we can start with 1 also. Okay, so 2 over 1, you are getting 2. So n approaches to 0, meaning this number should be smaller and smaller. So n becomes, so maybe 0.01. So 2 divided by 0.01, what are you getting? So you will be getting to 100. Okay, then after that, n equals to, let it be smaller and smaller, approaches to 0. So 2 over 0.0001, you will be getting 2. Okay, so you will be getting you will be getting 20,000. 1 2 3 4 1 2 3 4, yeah, correct. Okay, so if let's say I continue on 0.000001, so 2 divided by 0.000001, what I'll be getting? I'll be getting 2, 1 2 3 4 5 6. I will be getting 2 million. So what you can realize is when the n value here actually decreases and nearer to 0, what happened to all this number is actually increasing nearer and nearer to an infinity number. So that's why a over n will be equals to infinity. So I want you to write down these two terms and put it beside your notes, and it will be helpful when we talk about the concept later on. So this one will be approaches to infinity, then this one approaches to 0. So you remember these two, then later we'll be putting this concept together when we learn the content next one. Alright, so now we are moving into the content of today, so which is improper integral. Okay, so let's look at this graph here. So this is the content that we actually already learned in last week, which is how to find your area. Okay, so in this case, now you have this graph and this curve. So meaning for this one, how do you actually can find the area for the shaded region here? So normally you will have a limit which tells you what is the upper limit and what is the lower limit. But in this case, what you can realize here is you only have the lower limit, which this graph can continues to draw until infinity, which you don't know where it stops. So how do you find the area? So you will write it in this way. So meaning that now is actually the curve and the x-axis, so it's going to be dx and then y, and then your lower limit start at 1, and then your upper limit you don't know where it ends, so it's going to be infinity. So when we substitute our y inside, then it will be from 1 to infinity and then 1 over x squared dx. So this is actually how do we find the area here. Okay, now for number 2, let's work out this one when the n equals to different value. Okay, so let's say I have n1 and then x -2 dx. Okay, so let us do the integration first, then later we just substitute. Okay, so -2 plus 1 you get -1, so -1 divided by -1 you get -1 also, so it's going to be -1 over x and then 1 and n. Okay, now let's try on with all this value. So when n equals to 2, so meaning that, okay, maybe you can write this out. Okay, so when you substitute n, you are getting -1 over n, and when you substitute 1, you are getting +1. Okay, because minus -1, so you get -1 over n and +1. Okay, so what happens if you substitute all the different value here? So if n equals to 2, meaning that it's going to be -1 over 2 plus 1, and you're going to get 0.5. Okay, move on, 10. So -1 over 10 plus 1, you will be getting 0.9. So move on, -1 over 100 plus 1, I will be getting 0.99. So -1 over 10,000 plus 1, then I will be getting 0.000. I'm sorry, I'll be getting 0.9999. Okay, then after that, if I continue on, -1 over 1 million. So when I do plus 1, then what do I get? I will get 0.9999. 1 over, yeah, let me check. -1 over 1 million plus 1. Okay, yeah, correct. I'm getting 59. Okay, so what happened here is when you look at this, right, when the number for n actually increases, become greater and greater, the number here, okay, so here is actually become bigger and bigger to infinity. So all the number here is actually increases also, and it's going to be have a cap there. So the cap here is actually 1. So that's why, what do you think the value of 0 to infinity for 1 over x squared? So we will say that for 0 infinity 1 over x squared dx is actually equals to 1, because everything here is actually approaches to 1. Where we will say that when you can see this one, okay, when we have 1 and 1 over x squared dx, right? So what happened here is when your n actually approaches to infinity, so meaning when n getting bigger and bigger, what is the number here? So the number for 1n for this integral is actually getting bigger, getting nearer and nearer to 1. So that's why we say that the integral for the limit 0 to infinity for 1 over x squared dx is actually equals to 1. Okay, so this is actually our first type of improper integral. So the idea of this is like, when you look at this, right, am I going to do this for every different function if we want to find the limit? So it's quite impossible because I need to try out all the different value for every function. So that's why we need to use algebra to solve this. So now we'll be looking at how do we solve this like in mathematically. Okay, so before that, then let's talk about what is the improper integral first. So we are learning for the first type here. So for the first type is actually integral where one of the limit is infinity. So meaning that it can be from a to infinity or like from negative infinity to a. So as long as you have an infinity for your limit for your integral, that will be called as improper integral. So now we'll be learning how to solve this mathematically. Okay, so let's look at number A. So you look at this is exactly the same graph, that the same thing that we have solved just now, but now let us try to solve this by using algebra, like without doing the try and error with every number here. Okay, so number 1A. So the first step that you need to do is substitute infinity with n. So it's like what we have done just now. Instead of writing infinity, which we cannot solve, we change it to n. So the first step that you need to do is change your infinity to n. So meaning that I'm going to write 1 n and then 1 over x squared dx. Is that alright? So basically copy down the thing but then changing your infinity to n. Then after that, I will solve this like normally. So 1n and then x minus 2 dx. Now I'll start to do my integration. So this one will give me negative 1 over x and then 1n. Then after that, I will start with my upper limit first, right? So n substitute, I'll get negative 1 over n and then minus negative 1, which gives me plus 1. Okay, so after you have get this term, then after that, what you need to do is, you see, instead of writing infinity, we are actually putting the infinity as n. So what do we need to do next is, we need to find out when the n approaches to infinity, what we will get. So as the n here is actually going to be approaching infinity, right? Okay, so what you can imagine is for negative 1 over n, which is the term that contains n here. So when n is approaching infinity, what happened to this fraction? So it go back to the prior knowledge that we actually did just now. So remember, I tell you the first thing. So when n approaches to be infinity, anything in fraction, as long as your denominator is infinity, your fraction is going to be approaches to 0. So that's why negative 1, when n approaches infinity, negative 1 over n is going to be approaches 0. Is that okay? Then after that, if this term is approaches 0, which means like it gives 0 value to this function, so meaning that 1 to infinity 1 over x squared dx will be equals to 1, because negative 0 or like 0 plus 1, you are getting 1. So you see from the experiment that we have did just now, so you see you are getting the same answer as the value is going to be equals to 1. So this is how we solve it in a max way. Okay, so let's try out with B. Okay, so the same thing. The first step, change your infinity to n. So 1 n, then this one, if you can change, you can straight away change it. So 2x minus 3 dx. Then after that, I can start to do my integration. So negative 3 plus 1, I get negative 2. So 2 divided by negative 2, I get negative x. And then it's going to be negative 2 for my power. So I'm getting 1 over x squared. Okay? And then n, 1. So the same thing, I'm going to substitute n first. So negative 1 over n squared. and then minus minus, I get a plus 1. Okay, so try to do a complete step if you can. Okay, then after that, when you get the term, then now you can start to say that as your n approaches to infinity, negative 1 over n squared is actually, so the same thing. Whenever you have infinity square, then are you still getting infinity? A very big number, when you square it, is actually even bigger. So that's why infinity square, you are still getting infinity. 1 over infinity, you are going to get approaches to 0 also, because a over n will be approaches to 0. So that's why as this one approaches to 0, so your answer will be left with only 1. So that's why for this improper integral, your value is actually equals to 1 also. Okay, so let's try out with the next one. Okay, so for C, now we have an integral, so it's actually the same, but 2 to infinity and then 6x4. Okay, so let's try to change it into index form and then rewrite our integral. Okay, so 2 infinity, so instead of writing 2 infinity, we will write 2n. Okay, so 2n and then 6x negative 4 dx. Then now we can start to do integration. Okay, so integrate negative 4 plus 1, you are getting negative 3. So 6 divided by negative 3, you are getting negative 2. So negative 2x power negative 3 and then n 2. Then now you can rewrite them. Negative 2 over x cubed divide, n 2. So now you can substitute negative 2 over n cubed, negative negative is going to be positive, then 2 over 2 power 3. Okay, so negative 2 over n cubed plus, so 2 cubed you are getting 8, so 2 over 8 you are getting 1 over 4. So now you can say that as n approaches to infinity, so you say this one, negative 1 over n cubed. So it's the same thing. If n approaches to infinity, when you square that, cube that number, is going to be infinity also. So 2 divided by something approaches infinity, you are getting this fraction to be approaches to 0. Then after that, we can say that 2 to infinity 6x4 dx is actually equals to, so this one becomes 0 already. It's not like becomes 0, but approaches to 0. So when you plus 1 over 4, it's going to be 1 over 4. So that will be your answer. Okay, so let's move on for D. Okay, so the same thing, but this time maybe we try to move the 10 out so you can see the difference, but it's actually the same thing lah. Okay, so if you want to move the 10 out, you can move the 10 out. So the same thing, we are substituting the infinity part to be n, and then 0, 3x plus 2, negative 2 dx equals to, and then you can start to do differentiation. So integration. Okay, so negative 2 plus 1, you are getting negative 1. So 3x plus 2, negative 1, divide by your power, divide by your a, which is 3, and then n 0. So now you can rewrite, sorry I write a bit here because, yeah. Okay, so 10 and then negative 3. So now you can move them in. So negative 10 over 3x plus 2. Okay, and 0n. So now you can try to substitute. Okay, so substitute n here. Negative 10 over, if you want you can straight away expand them, is totally alright also. So 3n, so meaning 9n plus 6. Okay, then after that when you substitute 0, you're getting minus 10. And then 0, so 3 times 0, you are getting 0, so 3 times 2. Okay, then now you're getting the term already, so let's simplify this. Then plus 10 over 6, you're getting 5 over 3. Okay, so now let's see this. So when n approaches to infinity, okay, so what happened to 9n plus 6? So you can see when you substitute, when you have a number that approaches to infinity and you times with 9 and you plus with 6 is going to be infinity also. So that's why negative 10 over 9n plus 6 is going to be approaching to 0. Okay, so it's the same thing like a over infinity, then it approaches 0. So after that, your answer will be 0 infinity 10 over 3x plus 2 square dx equals to, what do you left? 5 over 3. So that's example D. Okay, so let's move on for the next one. Okay, we have 4 more examples for this question. Okay, so for E, it's the same thing, but now it's not the upper limit that is infinity, it's the lower limit is infinity. So equal to, then, let's do the same thing. So change your infinity to n, and then 1 over x minus 3 dx equal to, then now you can start to do integration like normal. Okay, 1 over x, negative 3 plus 1, you get negative 2, divide by your power, divide by a. Okay, then after that, you can simplify this. So you are getting 2 here, so it's actually 1 over 2, then 1 minus x squared for 0 and n. Then after that, what do you need to do? Then you can continue to substitute your value inside here. So which here will give you, but you must remember, so this is your upper limit, this is your lower limit, so you need to substitute 0 first. Okay, so when you substitute 0, so maybe we write everything down. So 1 over 2, 1 minus 0 square, then minus the second one, 1 over 2, 1 minus n square. Okay, then after that, equal to, so 1 minus 0, you get 1, so it's basically 1 over 2 minus 1 over, you don't need to expand this, it's totally fine. Okay, then after that, same thing, as n approaches to infinity, so what happens? So 1 minus an infinity number is going to be a very, very small infinity number because this is negative. So negative infinity is a very, very small number. So when you have a very, very small number and after that, 1 minus the number is going to be like approaching to 1. Then after that, when you times 2, it's still going to be a very, very small number. So after that, meaning that 1 over 2, 1 over 1 minus n square is approaches to 0. So that's why your answer for negative theta 0, 1 over 1 minus x cubed dx will be equals to, what do you left here? 1 over 2. Okay, so that's it. Then after that, we'll be looking the other example. Okay, so now let's continue on with second example. Okay, show that the following improper integral does not exist. So does not exist, that meaning that the product that you will be getting is like something that is undefined. Okay, so how are we going to do that? So it's going to be the same thing. So solve like normal first. Okay, so this is for 1 over 2 square root x, 3 to infinity. So we are changing the infinity to n for your first step. So 3 n, and then let's change this 1 over 2 x negative 1 over 2 dx. Okay, then after that we continue on with differentiate it. So negative 1 over 2 plus 1, you get 1 over 2. 1 over 2 divided by 1 over 2, you get x. And then 1 over 2. So n 3. So this is basically the same thing like if we write square root x. So what do we get? So it's basically square root n minus square root 3. Okay, so now we already got the expression already. Then we continue with as n approaches to infinity. So meaning that when the number inside the square root become infinity, so what happened to the square root? So you can imagine if the n here getting bigger and bigger, what happened to the square root? The number after you do square root is going to be greater and greater also. So this one will be approaching to infinity also. So an infinity number minus square root 3, you are still getting infinity. So that's why this improper integral will give us an undefined answer. So that's why 3 infinity 1 over 2 square root x dx is undefined. Okay, so undefined meaning that you don't have a certain limit for this. The number will be getting greater and greater. Okay, so now let's look at B. Same thing. Let us change it. So 0 to n, and then 3x. So 2 plus 1 over 2, you are getting 5 over 2. So negative 5 over 2 dx. And then equal to, okay, then you can start to do different integration. Negative 5 over 2 plus 1, you are getting negative 3 over 2. So 3 divided by the number, you are getting negative 2x, negative 3 over 2, and 0. Okay, so if you want, you can write it in square root term. So x cubed. Oops, sorry, this is negative. So it's going to be negative 2 over square root x cubed. Okay, so the first thing, you substitute n first. Okay, then after that, substitute 0. Okay, so now let's continue to solve this. As n approaches to infinity, okay, what happened here? So negative n 3. So just now we said already, so anything for your denominator is actually approaches to infinity. So 2 over the infinity, you are getting to get something that is approaches to 0. So this one you have a definite value. Then what is that actually make this improper integral does not exist? So let us continue. You look at this term. Yeah, so you have something that is 2 over square root 0. So can 2 over so square root 0 basically meaning 0 lah. So 2 over 0, what is this number? Anything that is going to be divided by something that is 0, you are actually getting a undefined answer. So that's why 0 to infinity for 3 over x squared square root x dx is actually undefined. Okay, because of this is undefined, so as long as this approaches to 0, so anything that is very small, when you plus an infinity number, it still gives you infinity. Okay, so let's move on to the last question for this part. Okay, given that the area of this shaded region is 1, find the value of A. Okay, so how are we going to do that? So the same thing, so write down the equation for your area first. Okay, so for this one, area for the shaded region, so you can see the lower limit start with A, then after that it continues on like without any limit. So that's why the thing that we actually want to find the area here is basically from A to infinity y dx, because it's the curve and the x-axis. So equals to A infinity, then we write down our y, so 24 over square root x x cubed dx. So equal to, then we continue to solve this. So let's change it to index first. Oops, I'm sorry. So you want to solve this, you can't do that. So after that, we need to change our infinity to become n. Okay, so n, let's write here. So n a, and then 24 over square root x cubed dx is actually equals to n a, and then 24 x negative 3 over 2. So it's just like what we have done just now. So like instead of writing theta, we are instead of writing infinity, we are substituting the infinity with n. Okay, so now you can start with your normal integration. So plus 1 you get 1 plus 1 you get negative 1 over 2. So 24 divided by negative 1 over 2, negative 48, and then x negative 1 over 2, and then na. So equal to, then you continue to want to write it in this way. Okay, then n 0. So now let's substitute n. Substitute a. Sorry, this is a. Yeah. Substitute a. Negative, negative, so plus. Okay, then after that, when you get this term already, then now you can start to find out when n approaches to infinity. So as n approaches to infinity, what happened to negative 48 over square root n? So same thing, something divided by an infinity, so it will approaches to 0. Okay, so that's why this term actually left with 48 over square root a. So that's not your answer yet. So the question tells you that the shaded region is actually 1, meaning that this term is 1 equals to 48 over square root a. So square root a equals to 48. So a will be equals to 48 square, which gives you 2304. Okay? So that's the end for this part. Then later on we are going to see the next example for type 2 improper integral. Okay, now let's move on for the second type of improper integral. Okay, so just do some revision. So the first one that we are saying that for type 1 is that when integral have one of the limit as infinity. So this is called as type 1 improper integral. So now let's move on for the second type. So the second type is integral where your function is undefined at one end of the interval. So what does that mean by undefined at one end of the interval? Okay, so now we are trying to look at this example, then you will understand. Okay, so now you have an integral from 0 to 4 for the function 5 over square root x dx. So what you can realize here is that when I substitute 4 inside this function, right, then I'll be getting 5 over square root 4, which gives me 5 over 2. But then when I substitute 0, then what happened here? I got 5 over 0, which actually give me an undefined answer. So this is what is that mean by undefined at one end of the interval. Okay, so you can see for this type of question, they don't have anything like infinity in the limit part, but it's that when you substitute the value into your function, you are getting something undefined. Okay, so let's try to solve this question. So how are we going to do this? It's going to be the same concept like how we solve the type 1 improper integral. But for this one, your first step is that you need to find out which is the value that causes your function to be undefined first. So in this case, is when you substitute 0. So that's why we'll write down there the function fx equals to 5 over square root x is undefined when x equals to 0. So meaning that when we substitute 0 here, we will get an undefined answer. So after we write it down, then the part that actually causes your function to be undefined, we will substitute it with n. So meaning for this part is the 0 that caused the function to be undefined. So that's why we will be changing the lower limit here to n. So n 4, then the other one just copy like normal. Is that alright? Okay. So you are only changing the 0, which is the value that caused your function to be undefined, change it to n. So it's like just now when we change infinity to n. Okay, then now you can continue to do integration. So for n, let's change this to index form first. So 5x negative 1 over 2 dx. Okay, then we can start to do integration. So x power negative 1 over 2 plus 1, you get 1 over 2. So 5 divided by 1 over 2, you get a 10. Then x 1 over 2, which gives you square root lah. Okay, and then for n. Then you substitute for 10, 4 minus 10, n. So square root 4 gives you 2, so 20 minus 10, n. Okay, so after you have this term, then just now we will write that as n approaches to infinity. So for this case, what is the n? The n actually represents a value that approaches to 0. So as n approaches to 0, then what happened? So 10 square root n. So when this number getting smaller and smaller nearer to 0, when you square root that number, you are getting something 0 also. So 0 times 10, you get 0. So this one going to be approaches to 0. So that's why for 0, 4, 5 over square root x dx is going to be equal to, so this one is approaches 0 already. So 20 minus something that very small approaching to 0, so you get 20 only. Okay, so now let's look at example 2. Okay, so the same thing. The first step that we need to do is find out what is the value that causes the function to become undefined. Okay, so 16, when you substitute inside, then of course it's something that you can solve. So it's the same thing here. When you substitute 0, you get undefined. So now let's continue. So the first thing that you need to write is write down the function. Okay, so the function fx equals to 1 over 4x cubed is undefined when x equals to 0. Okay, then after that, what's the next step? The next step is you need to change the number that actually caused the undefined to n. Okay, so you rewrite 16 n, now you can change this straight away, 3 over 4. Okay, dx equal to, then now you can start to do integration. So negative 3 over 4 plus 1, you get 1 over 4. So when you divide, you actually get 4. Then x 1 over 4, or you can write 4 lah. Okay, and then 16 n. Then now you can start to substitute. So 4 times 4, 16, and then minus 4 here and n. Okay, so 16 to power of 1 over 4, you're actually getting 2. So 4 times 2, you get 8. Then minus, so this part, you still copied it. Okay, so now you get an expression already. So you can write down as n approaches to, so in this term it's still 0. Okay, so when n is getting smaller and smaller and you do square root, is getting approaches to 0 also. So 4 times something that is approaches to 0, you are getting something approaches to 0 also. So that's why for the answer 16, 0, 1 over 4x cubed dx will be equals to, what do you left here? 8. Okay, because this number is going to be approaches to 0 already. Okay, so let's move on for the next question. Okay, so the same thing. We write down the function fx equals to x minus 0.99 is undefined when x equals to 0. Okay, so you can try it out. When you put anything, the base for your index is 0, you will get max error in your calculator. Okay, so now let's do it. So since x equals to 0 gives undefined answer for your function, then we're going to change the n to 0 to n. So 1 x minus 0.99 dx. Okay, then let's continue on. So negative 0.99 plus 1, you get 0.011, divide, then you get 100, and then x 0.01. So and 1. Then equal to, now we can substitute 100, 0.01 minus 100 and 0.01. So 1 to any of the power, you still get 1, so you left with 100 minus 100 and 0.01. So as n approaches to 0, what happens? So if n is a very small number that approaches to 0, and when you do a power of 0.01, the number is like getting smaller and smaller, and even you times 100, the number will be like very small, which is approaches to 0 also. So that's why for 0, 1, x negative 0.99 dx, your number will be equals to 100. Okay, so that's the example for this one. Then we'll look at the last example for the does not exist. Okay, so show that the integral here does not exist. Okay, so first one, the first step is the same thing. So find out what the function is undefined when x equals to what. So for this case is also 0. Okay, so the function, sorry I write here because I scared that I don't have enough space later. So the function fx equals to 2 over x cubed is undefined when x equals to 0. Okay, then now we can continue on by changing the 0 to n. 2n 2x negative 3 dx equals to, then we start to do integration. So negative 3 plus 1 you get negative 2, so minus 1 over, left with 2, so x squared and then 2n. Okay, now you can substitute negative 1 over 2 square minus 1 over n square. So you get negative 1 over 4 plus 1 over n square. Okay, so now as n approaches to 0, yeah, so 1 over 0. So you remember just now the prior knowledge. Okay, when you have your n approaches to 0 and you have 1 over n square, this thing will be approaching to infinity. So that's why this will be approaches to infinity, because like n is nearer and nearer to 0, so meaning n is getting smaller and smaller, meaning the value of your fraction is getting bigger and bigger to infinity. So that's why then after that we can say that anything negative 1 over 4 when you plus undefined answer is going to be undefined also. So that's why 2, 0 to negative 3 dx is undefined. Okay, so for b, the same thing. Let's write down. Okay, the function fx equals to 2 over 3x minus 1 square is undefined. Okay, so for this case is undefined when what? So when you substitute 2, you are getting 5 square, right? So it's fine. But when you substitute 1 over 3, you get 1 here, 1 minus 1, you get 0. So anything for the denominator part is actually cannot be equal to 0. So it's undefined when your x is 1 over 3. So now our next step is we need to change our 1 over 3 to x, to n. So 3, 2n, and then 2, 3x minus 1, negative 2 dx. Now I can continue to do my integration. So in this case, I'll have 2. It's like a constant, so you can just write it down. Negative 1, and divide by the power, divide by the a. So 2n equals to, so rewrite everything. So 2 over negative 3, 3x minus 1. Okay, so it's fine if you don't want to expand it, so you just leave your answer like that, then we expand it here. So you can substitute your 2 inside, so negative 2 over 3, 3, 2 minus 1, and the other one is like minus 3, 3 and minus 1, sorry, this is 2. Okay, so equals 2, so 3 times 2, 6 minus 1, 5, so negative 2 over 15 plus 2, sorry, this is minus. Okay, so plus 3, 3 and minus 1. Okay, so now we have this expression, then we can write that as n approaches to 1 over 3, which is the n that here we are substituting 1 over 3, it's not 0 here, okay? So when n is approaches 1 over 3, meaning that this number will be approaching to 0 also. So that's why 3 times 3 and minus 1 is going to be approaches to 0. Because when you sub 1 over 3 here, you are getting 0 here, so meaning that the number that you get is certainly will be approaching to 0. So when 2 divide by anything approaching to 0, it will be approaching infinity. Okay, so that's why negative 2 over 15 plus anything infinity. So your answer will be 2, 1 over 3, 2 over 3x minus 1 squared dx is undefined. Okay, so this might be like something very new to you, but I think when you try out question, then you will be more comfortable with it. Then you must make sure that you can understand this part. So as long as everything is just like how do you use this in like different terms of function to find your answer. Okay, so that's it for improper integral part. So stay tuned for the next video about your video of revolution. Alright.